Thanks for having me, everyone. I'm really happy to be there again. With this talk, we're going to talk about design systems again, and we're going to talk about legacy stacks again, but as we said, in a less optimal context. So in this story, we will talk about bringing a almost 20 years old legacy web stack to something more modern and more organized than before, but without sacrificing a lot of different things. So it's a story about the future. And what the future? Because it's future front-end, and because we are bringing a web stack back to the future into a modern stack and modern architecture. But also because it's a way to me to be back again, because I was there for the React Finland twice, so I'm really, really happy to be back again. And thanks to all of you to having me on stage today. So what is that? All my stories start with that, which is a kind of dashboard panel. This dashboard panel was made for a company named Always Data. It's a PaaS provider I was working for. And with this PaaS, we had some kind of administration interface, something like that, where people could configure their website, containers, solution, providing workers, and so on, blah, 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 you name it. So it's a very old stack, and our plan was to move this one from something very old to something, I guess, brand new. So I'm mad. I'm working in the web for more than 20 years right now, so I'm a bit old right now. And I saw a bunch of things that you don't want to see, I guess so, but yeah, we need to work with that. So this is exactly my story about bringing this old web stack to a modern front-end. So what are the origins about that? So as I said, it was an old, very old web app. It really was time to modernize the stack and to modernize what we had at this time. The fact is, the team working at Always Data is really a team of engineers, and almost just like that. It's a small team and small company, but every people are engineers, and none of them were front-end developers. So they were doing front-end because it wasn't that complicated to build a dashboard of different widgets, but they are not really used to develop a real good front end. So at some point, I was just asking for people handling the front end in the team, because we weren't really able to push the things a bit forward, and we needed to just increase our productivity and the way we are delivering the product. So I asked for a front-end developer, and after a bit of negotiation, I finally had one. And the first thing that we had to deal with him was, okay, what do we have now and where we want to go? Because we didn't have anything, not even a UI kit. We had nothing to build our web pages and just working with a bunch of different tools. It was a Django application, so a Python application in the Django ecosystem, so a multi-application solution based on Django with a lot of different applications, because in the same Django core, we're running the dashboard that we saw, but also the website and also the different applications to manage databases and the webmail and so on. So everything was a different application into a single core application made with Django. So it was a multi-app context. We just used some bootstrap thing. So it was bootstrap with a bit of jQuery, and that's all. It was an 18-year-old code base. And we've got a few APIs for luck. Some publics for our clients, some private for internal use, but we didn't have API for every part of the platform. Just a few of them, which wasn't really easy. So how it worked exactly? It was something like that. You've got your agent is making a request to the Django framework, and the Django framework is generating some HTML. And while it was generating this HTML, it was also consuming some assets, passed it to a Django compressor. Django compressor was a plugin dedicated to Django to package everything like we had Rocket for Ruby on Rails in the past. So it was definitely not made for a modern front end. It was something really oddly opinionated, I said, something like that. So all those third parties were also injected into that. We were using Webpack behind Django compressor to package every part of the application to try to do something like more modern, and it was a bit spooky at some point. Okay, so we didn't work to work again with this stack. We need something more modern because we had the Django compressor, I said, we had Webpack, we had some kind of external assets, some bloated styles everywhere. Some inline scripts inside every kind of views that were generated with Django. We had some external scripts. We had some data inline into the views to be consumed by the script inline into the views too. And a bit of mess of internalization because some part of the application were translated using Django and passed as a JavaScript variables into the rest of the application. So we had to deal with that and to modernize everything in this context. So it was a bit complicated at first. What we were sure is that we want a component-oriented design. So something that we were able to modernize in a way we could handle an atomic design and put some atomic design concept into the development of our web pages. Because we wanted to be the pages of the views being composable, like I'm taking different kind of elements and I'm just aggregating them to build some views. So the engineers could be focused on just building stuff and layout inside their views and not dealing with the whole rendering of the different parts of the application. We want something nicely crafted to be able to push this architecture a bit further and to maintain it in the future. So something like a clean architecture that we mentioned previously, something like that. We want something like a solid design where we can substitute different parts when we need it. So it was really more well architectured than what we had before, coupled with a living documentation. So the different engineers could be able to understand how to use the different components and how they can be embedded in different parts of the apps and so on. And a distributed core asset. So everything should be packaged at some point and ready to be consumed. That was the idea. So finally, it's a library and component and a system built for the platform by the people doing the platform inside. We wouldn't probably not rely on an external set of components, library of components, something like that. We wanted to provide a set of templates, like layouts or something like that, to be able to build the pages, build the views, and so on, and for sure, simplify DevX. So we needed something that worked out of the box, even when you bootstrap new views for new parts of the application, new services that we will host in the past, and something like that. We want something battery included, but with no need to supercharge it, because days after days after days after years, we finally had some bloated script or bloated styles that were just contributed by the engineer saying, okay, this table don't look good in my new view. I don't know why, so I'm just going to fix it in another part of the CSS file. And it's just another addition over another addition. And we don't want that to be done again in the new system. And something that where engineers don't have to deal with the delivery. And they should probably just have to put everything together, and the delivery of the front-end assets would not be handled by the engineers at the end. So something definitely out of the hand, just to simplify the developer experience. So let's frame it. It's just a design system that we wanted to build at some point. And we were totally okay with that. The thing was that we won't get rid of different things. We will stick with Django for obvious reasons, as the stack was 18 years old, and we wouldn't change that at some point. It was a team of Pythonists really used to Django, so we won't change their rabbit on this point. We wouldn't want to migrate the full platform to a first, an API first platform or architecture, because we didn't have the time to do that, and it will make no sense at some point. So having a new web application entirely powered with React or Vue or whatever you want, and really to consume some APIs to manipulate the platform and data in the platform was totally out of scope. We didn't want to do so. And we wanted to remove the Django compressor hell, because it wasn't just maintainable anymore. So we wanted to go back to something simpler and easier to use. So what was the tech foundation of that? We should have chosen the way of web components. I suggested it. But at that point, the engineers just say, okay, we won't go with web components for a simple reason. It's probably too complicated for us. It's web-based, and we are not front-end web developers. We are more a team of CSOPs and backend Pythonist engineers. So we want something that we can understand when we access the source of the design system. So we want to stick with something that we can understand, and web components logic are a bit way too far from our comfortable zone. So we get rid of the web component solution, and we were step back to the Django solution. So the first challenger is Jinja-X. Django has different kind of template engines. Jinja is one of them, and Jinja-X is an extension of Jinja that allows you to build some kind of X component like GSX or TSX components, but directly with a Jinja syntax. So it allows you to define your different kind of components that are ready to consume, like HTML tags. The great way is that you can define some props, and you can consume those props directly into your markup, like you did with just Jinja and some variables. So it's not that far from their previous habits as a backend developer, let's say, services developer. I prefer this term. And the good thing is that it can embed related assets. Like, okay, for this component, I need those CSS files and those JS files, and you have to serve them right now. And Jinja-X is intelligent enough to just gather everything and gives you a list of the different assets that you need to embed in your final view to have it running. So I can generate a page with a lot of components in it, and all those components will tell me which kind of assets that I need to include, and same thing for the CSS file, for the JS files. So it's a trade-off that we can work with. Second challenger is a JavaScript solution to be able to run the component, because right now we are just serving plain HTML to the browser. So we need to manipulate and to, kind of iterate with logic those components, like web components could do. And we did so using Stimulus framework, because we tested a lot of different things, and Stimulus was probably the best balance between the complicated part of handling a new framework with a lot of batteries included and so on, like React and so on. And they could handle the existing markup by just hooking on the existing markup and powering it with some kind of logics. It's a way to declare it that is quite close to web components. So it's also a solution to push progressively the services developer to a more web component-oriented approach. But in the meantime, it's a good solution to consider. And we still had the problem of CSS and how to use CSS and how to exploit CSS in a way that we won't create some side effects when we load different parts of the components at some point and so on. So we choose to stick with Cube CSS, which is an approach like BEM, but where BEM is fighting against the CSS concept. The Cube CSS is just embracing the concept of cascading and inheritance that is built into the CSS concept in the end. So it was our choices: Jinja-X, Stimulus, Cube CSS, and we were able to produce some kind of components ready to be generated by Django in its template views, but ready to be powered and to be rendered directly into the browser without any kind of pain, I guess so. We needed a supporting team for that, so we chose to work with Figma to just work with the design because it's an industry standard, just to collect the legacy, because starting with an existing code base was really difficult, and you can't start a design system from scratch because it will be too complex. So we need to grab the existing content, inject it in Figma, and then work with the existing stuff to just, making a catalog, a library of the existing components and starting to build the interface and to restart new interface. We used a plugin for Figma called HTML2 Design, which is really efficient for this kind of work. So we were able to refine the components in Figma, create and managing the design tokens directly into Figma, and then export them to be ready to be used in the Cube CSS-oriented file. We chose to finally use Vite rather than Webpack for obvious reason. It's the way to go right now if you want to package different kind of assets. With Storybook, because it's an industry standard, and to define workflows to the different parts of the team. So the engineers could be ready to contribute to the design system, and we were ready to handle those requests, but they can't have the authorization, let's say like that. They weren't allowed to directly supercharge the different parts of the components that they were working with. It worked well because it was a small team, and we were really able to deal with it quickly when we had a new request coming from them. But we still had some unknown parts, like how to deal with configurations. We don't know at this point. How to work with a properly architectured component, so how to distribute them and how to give the users the way to build the different views. How to make Vite and Django work together. We didn't know. How to use components outside of Django, because if we wanted to display those components into Storybook, how to use Nginx in Storybook. We didn't know at that point. And how to package everything from production, because it's a nice idea, but how to put it in production finally. And finally, the idea was we didn't want it to be a big bang, like replacing everything and running, but something really progressive in the evolution. Not to lose our final users in the overall experience, and just to be sure that everything were working at first. So the idea was to replace the existing build stack, Django compressor and Webpack and generated views and blah, 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 with the new one without any change visually, just to be sure that everything is working. And after that, we will be ready to make some baby steps to implement the changes into the design and moving progressively into a whole design system-oriented solution. So how we did that? We had to start it somewhere. So we created a new app, a new package into the Django core, named UI, and this package will be responsible to handle everything dedicated to the design system and the UI stuff. It was responsible to host different things like configurations. Everything was in the UI package, different kind of helpers, just to help to import some things and so on. The different plugins, different kind of templates ready to be consumed by the final users, and the components themselves, obviously, and the assets related to that. And we wanted it with no dependencies to any kind of other packages in the core Django. So the apps in Django will be dependent on the UI package, but the UI package will be totally standalone and totally able to work outside of Django if we needed it, and we will need it for Storybook. So we created a sandbox with a simple demo app, and we started to work with that at some point. The first thing was gluing the parts together. So the first idea was we've got one app. Each app was one workspace in the PNPM sense and one package in the Django ecosystem. One app, one PNPM workspace, one package. And everything is properly, arranged in the code base. We created a lot of different Vite custom plugins dedicated to a small part. The first one was to reading Django config directly from Vite. Because if you want to start with having a design system powered by Vite to package a web application, but Django need also to know where to contact Vite at some point when you are running in the development mode, or when you are dealing with where to put the different assets generated and so on. You can have different source of truth for the configuration too. So because the application was developed by the service developers that were used to Django, we stick to the Django configuration. We generated a JSON file from the Django configuration ready to be consumed by Vite. And then in the Vite config, we just extracted the content. So one source of truth for the configuration, it was in Django, and everything was read directly by the Vite config when needed. We were ejecting all the images as references because when you are developing a full JS application, you can import your assets and import your images, but we won't do that because images are just, written in the HTML generated by Django. So we needed those images to be grabbed by Vite and packaged by Vite. So Vite needed to be aware of the existing images. So we forced Vite to consume all the images in the code base and injected them in Vite with a dedicated plugin. We produced an SVG sprite for the icons, and we generated a manifest.dev.json. Why? Because Vite is able to work with backend solutions like Django or like Laravel in PHP or Ruby or whatever you want. But to do so, the backend frameworks need to be aware of what Vite has generated during its process. So they use the manifest JSON file produced, which is just a mapping between you ask for the index.js file, this is the generated file that is containing your JS index file, and that you need to embed in your final application. Okay, so it works well in production mode, but you also needed that in development solution just to be able to, to map the right thing at the right place. So we built a little plugin to do so. Then we created a Vite-based config, which was a common config for all the application, embedding all the Django concepts that we need to address, like where to put the static web files at the end and so on. So we did so, and every application in Django will have its own Vite config consuming this base configuration. And we made a custom tag in Django to just include the Vite.js file, which was something like, okay, we will use Vite and we will need those JS assets in this specific view. So let's do your magic, find in the manifest the right file that were generated for those asks at this point and inject them in the final views. So it's a bit of magic, and we had a bit of magic over it, like caching the generation of the configuration, reading directly from the Django templates to be able to automatically set the import endpoints into the Vite config, auto-importing different kind of components. The idea is that we just wanted to enhance the developer experience at the end. And because they were Pythonists, we stuck to the Python ecosystem. So we use Poetry, which is a standard to contain the environment for the developers. We used Poet, which was a task runner dedicated to Python to wrap the JS task, and we were using PNPM called by Poet to run the different part, which means that for the backend developers, it was just like, okay, run dev mode for this application, and everything was launched. The Django framework, the Vite development mode, and every asset will be mapped together, like the Django application know where to call the backend framework, the backend solution powered by Vite for the static assets and so on. So we have some kind of shell ready to run the overall application. So now we have to migrate the code base inside it. So what we did was something where we don't want to break the system. So we started by moving the base legacy templates into the UI package to be able to have it available everywhere to be extended in the Jinja templates. We were replacing Django compressor and get rid of it and moved to Vite, so we had something that worked. And then for each application in the core, we had to create a Vite config file ready to consume the base command part. We were extracting scripts, all inline scripts, in dedicated files, and we kept the data in data blocks into the views when we want to consume this data coming from the backend into the front-end components, into the front-end views. And we created a cheap feed flag system, like, okay, we are in a view, in this view, we will have charts, and because this kind of view could be used with or without chart, or with a legacy version and a modern version, we just, in the Django template, enable a flag, and we can read this flag directly into our JS files to load dynamically the different modules responsible for, okay, I want to load this specific part, this specific component, and so on. It's working, not that bad, I guess so. About the delivery, we let Vite build everything, so packed everything for the application, for each workspace. So each app were responsible of its own final assets. We packaged everything using a building Django function, which named collect static, which is just collecting, as the name said, every static in your Django core into a single endpoint. We packaged everything and pushed it in production in a version CDN, which means that prior any upgrade in production of the platform of the solution, we were building the related assets, saving them in a new version, pushing them in production in a new, behind a new server version number. And we were able, when moving in production, to call the new asset, request the new asset, and everything is working well. And just in case everything went bad for some kind of solution, it was easy to roll back because the previous version of the static asset was still available. With some kind of magic again behind that, but I can talk about that later if you want. So one step at a time, we moved all existing code base to Vite. It was working pretty well. We put on the magic to make it compatible with the existing stack architecture using Django. We went well with the UI package, which were ready to handle the different new components and so on. And we built a simple component ready to be integrated just to demonstrate the way we will use new components in Nginx into our final application. So not a big bang, just a continuous progressive enhancement in our final application. It was great. It was working good, but it is not a design system. It is a collection of components, because the design system is also about communicating with the rest of your teams and the design and so on. So you need documentation. So how to document that? As I mentioned before, we choose to stick to Storybook, which is the industry standard at some point, at least at that moment, when you want to document your different kind of components. But how to use our Nginx produced components directly into Storybook? Some of you may know that, but Storybook came with a server mode that is available. So it means that in your configuration of Storybook, you can specify a server endpoint, asking it as a base URL to call your components. And then when you define your stories, you define an ID, which is finally the endpoint that you can call on the server to get the component, and a different set of props that you want to define. And that will be translated into a single URL that will be called on your server part to get the rendered component that will be displayed into your Storybook. And you could dynamically change everything into your Storybook interface, like with any kind of React or Vue component or whatever you want. So for this rendering part, we made a simple Flask application, which is also Python, which is ready to handle the Nginx template. So it was just a single API, ready to render the components, and to pass the rendering elements to the Storybook, which is something we call component as a service, which is really, really helpful when you want to distribute your components dynamically. We could do that also with web components if you want. We could do that with a lot of things. And it's pretty well. We discussed about it in the workshop yesterday. But because the page that is served is just HTML with references to static assets like JS file and CSS file, ready to power your components. We need to make a simple middleware to be ready to inject the dependencies needed by the component to be properly displayed, like the CSS file associated to that, and some kind of wrapper around stimulus to bootstrap the stimulus application, so the components will be ready to auto-register into the stimulus application in the end. So finally, it worked like a 2025 application, something more modern, like it's just building blocks in a legacy stack and a legacy application that won't have to evolve a lot in the future. All technologies were here, all technologies were ready. We just wrote a bunch of custom Vite plugins, but that's all. But they weren't ready to work together, and we had to use a lot of glue to make everything working well. But in the end, it was working not that bad, and we built an overall ecosystem around the design system in an existing legacy Django code base, a very old one, but ready to handle the new challenges of working in a new era of modern front end with a design system directly into it. Thank you very much for your attention.